the data that we need we can derive from these older bones. So although the bones are old, what we end up with in the model is the simulation of a living spine.
I, as an anthropologist, am providing access to data and providing access to analytical techniques which are going back into biomechanical engineering.
The unlikely combination of old human bones and the latest computer modelling techniques are being used to develop new ways of treating chronic back pain. Spines from around 40 skeletons housed in various museums and anatomy collections are being analysed in the research, which is taking place at the Universities of Leeds and Bristol. The computer modelling side of the work is led by Dr Ruth Wilcox at Leeds.
We're using computer models, the same kinds of modelling processes as we'd use in aeronautical engineering or in civil engineering to analyse structures, but using those types of principles to model the spine and to simulate how a treatment would work within the spine.
Ruth says they're carrying out the work using latest imaging techniques.
Microcomputer tomography scanning is imaging a specimen in 3 dimensions. So it's similar to the type of technique that we have in a hospital called a CAT scan. In the hospital, a patient is imaged by basically being x-rayed from different angles and then using that to build up a 3D image of the patient. This works in the same kind of way, but we're doing it at a much higher resolution so that we can see the individual strands or struts of bone within the vertebra. And that data we then put into our computer models so that our computer model simulates this variation in bone across an individual vertebra, but also from one patient to another.
The bone remains are being gathered and scanned at the University of Bristol's Department of Archaeology and Anthropology by Dr Kate Robson Brown. Kate explains why they're using such old human remains.
Most of the time, at the moment, we get material from the more elderly sections of the population. And in order to understand the range of variation within a normal population, we need to have information from younger adult age groups. By using older collections of dry bone, and these are macerated, which means cleaned, dry skeletons from those collections, it allows us to investigate bone morphology in age groups which are not accessible using recently donated material. One of the skeletons we're looking at is that of an adult female. She was quite little. She was around 5'2" when she died. She was probably in her late 20s or early 30s. We have her complete skeleton. This was a skeleton that made its way into the collection, we think, in the 1930s. And this particular individual has a very clean, dry skeleton, so there's no evidence of osteoarthritis, there's no evidence of bone cancer, anything like that. We can't tell from her skeleton what she died of, but it was certainly nothing that is represented on the bones itself.
Ruth says the new computer software will speed up the process of clinical trials for testing out new treatments for chronic back pain.
The idea by the end of this project is that we'll have these models up and running. A company could come in with their design for a new product and we could simulate how it would work across this population of different spines. So we could reduce the risk when it does go into clinic and prove beforehand that in our computer models that it's behaving as it should. And the good thing about the computer models is that we can use them over and over again, so we could test lots of different products on the same computer model. Whereas if we were doing this in a laboratory, then we'd need a new spine, a new donated spine each time we wanted to test a new treatment out.
Kate says the work could lead to tailor-made medical treatments and even provide new insight into how our ancestors evolved.
It would surely be great if we could be in a position where surgical interventions could be assessed for us as an individual against a model of our own bones. We're moving in that direction, but research like this is helping to provide the baseline data on which those developments can be made. One of the really exciting developments that's arising out of this for me as a biological anthropologist is being able to apply this type of modelling technique to fossil bones for which there is no other way of testing them. So, for example, we could take a fossil skeleton that's 3 million years old, scan a vertebra, make a model of it, and actually test some locomotory strategies to see whether that individual in life walked around on 2 feet or 4 feet. And that's a major development for evolutionary anthropology.
The research is funded by the Engineering and Physical Sciences Research Council. The computer modelling software is the first of its kind for back conditions. It should be available for testing out newly developed products and treatments in the next few years.